Now, we're going to be dealing with this in the bean bag isotope lab in a couple of days. Now, we talked about boron 10, boron 11, and I just gave you those percentages, didn't I? 19.9%, 80.1%. All right? I'm going to show you how we would calculate the atomic mass, which is on the periodic table. What was the number on the periodic table? Okay, who's got their periodic table handy? What's the number for the atomic mass of boron? 10.811. Okay, 10.811. Well, what we need to do is the atomic mass is equal to the relative abundance of isotope 1 times the mass of isotope 1, plus the relative abundance of isotope 2 times the mass of isotope 2. Now, we only have 2 isotopes for boron, so that whole bottom part of relative abundance of isotope 3, I don't need that. I don't need that. I only need the top 2. Now, I'm giving natural abundance. Relative abundance is just the decimal form. Okay? So, if my natural abundance is 19.9%, my relative abundance is 0.199. Okay? And I'm just going to use RA for relative abundance. Now, same thing. My relative abundance is going to be 0.801 for boron 11. So this is just a nice, easy calculation using this. Well, I know that the relative abundance of isotope 1 excuse me, is 0.199. What is the mass of isotope number 1? What is the mass of isotope number 1? What is it? 10. I add that to the relative abundance of isotope 2, which is 0.801. Multiply that by the mass of isotope 2, which is 11. So, when I do my calculation, 0.199 times 10 is going to give me 1.99. 0.801 times 11 is going to give me 8.811. When I add those two together, I get 10.801. Is that pretty close to the 10.811 that the periodic table has? Yeah. Okay. Pretty close right there. So that's where I'm getting that number. And that number is the average of all the isotopes. Now, I'm going to go down to the next part of this. Go ahead and copy this into your notes. This is going to be a little bit different because I'm given the atomic weight for lithium, 6.941. I know that lithium has 2 isotopes, lithium-6 and lithium-7. So I'm going to calculate the natural abundance. All right? I'm going to calculate the natural abundance. Well, based on my equation, I know that the atomic weight is equal to the relative abundance of 1 times the mass of 1. Well, the mass of my 1 right here is going to be lithium-6 plus the relative abundance of 2 times my mass of 2. So there is my equation right there. Now, the only problem is I have 2 variables here, Ra1 and Ra2. Okay? Ra1 and Ra2. But I know that these 2 numbers have to add up to be 100%, right? So I know that the relative abundance then has to add up to equal what? 1, right? So what I'm going to do is I'm going to have lithium-6 be X, so lithium-7 would be 1 minus X. Are we okay with that? Do we understand what I did right there? Because they all have to equal 100% for a natural abundance, so the relative abundance all has to equal 1. We okay with that? Now, I'm plugging those into my equation now. So, 6.941 is equal to X times 6 plus, and I'm going to use brackets because 1 minus X is Ra2 times 7. That should be a bracket. Don't know if I can erase that. Yeah, I can. My erasing wasn't working earlier. Okay. So, when I start doing, this is algebra, folks. This is an algebra problem now. 6.941 is equal to 6x plus, distribute that out, 7 minus 7x. I've distributed that out. Are we okay thus far? Now I've got to get my x by itself, and my number by itself. Okay? So, right here, what is 6x minus 7x? Minus 1x plus 7 is equal to 6.941. Well, I'm going to subtract 7 from both sides. So I get 6.941 minus 7 is going to give me negative 0.059 is equal to negative 1x. So what is x equal to? X is equal to 0.059. So, when I come back up here, all right, my relative value for lithium-6 is 0.059, which is equal to 5.9%. One minus 0.059 is going to give me 0.941 which is going to be 94.1%. Now I have calculated my natural abundance. Now, does this make sense? Isn't 6.941 a lot closer to 7 than it is to 6? Yes, so I would think that the more abundant of those two isotopes is going to be 7, not 6. Now, you're going to need those for the isotope lab in a couple of days. So make sure you store those in your notes where you can find them.